This is a BT30 Slitting Saw Arbor. I made just from a few pieces that I bought from AliExpress, and a couple of hours of time, probably not even that. So stick around and I'll show you how. The key component to this arbor is this BT30 indexable tool holder. I didn't realize these existed until I spent quite a few evenings just on AliExpress browsing machine tools. It's quite handy actually, because it's a long shaft. You can choose the length you want, and between 90 and 60 millimeters. It has different threaded holes based on what saw you want to use. So I found these slitting saws, and it seems to be the pattern that the hole, the inner hole, is always a sort of a fraction of the outside diameter. So I decided on 16 mil, and for me I can then use 50 and 60 millimeter OD saws, which are plenty for what I need to do. So I bought one of these and a bunch of these, and this is what arrived. It seems to be nice and shiny, nice surface finish, a nice long neck, and it has plenty of surface for the blade, for the disc, for the cutting blade to sit on. So here is a carbide slitting saw that I bought with a 16 millimeter inner hole, and it sits perfectly on the face there. So the idea is that we then retain this disc with a 12 millimeter cap head bolt, and all we need to do is just make a little spacer with some shoulders, so the clamping force is distributed nice and evenly across the ID of that slitting saw, and it's located as close to the axis of the tool as possible. And to make this little spacer, all we're going to use is a M16 bolt. The head of the bolt has plenty of meat to turn down the external hex points into a circle, and then drill a hole in the middle. So I stick my 3-jaw self-centering chuck on, stick the bolt in, and start cutting the OD of this spacer slash adapter. At this point it's an interrupted cut, so it's not very kind on the tool, so I just decided to use the biggest insert I had. My tool post is not supposed to be able to hold 12 millimeter tools. Also, those massive long M8 bolts, I just forgot to turn them down because the original holes were all chewed out, so I had to rethread them. So yeah, ignore all that, that's work in progress. Light passes to start with, and then the end pass I kind of laid into it a little bit, and got some nice blue chips. So just facing off the front there, and then a little chamfer on the front and on the back. I quite like using this tool because it basically does all the operations in one tool. It's quite nice. Then I spot drill the center, and then I use I think a 5 millimeter drill bit, HSS Co, just because I like the cobalt bits. They're much harder to chip the corners. And then a 10 millimeter bit, and then I decided to sneak up on the final ID with a boring bar. I used this little Glanz boring bar with indexable bits. It's really quite nice actually. It's small, so it's a little bit flimsy, but as long as you take light cuts, it's perfect. So I'm just eyeballing the center height here. I've pretty much just eyeballed the whole thing. I haven't really taken any measurements other than just to make sure that it's going to work in the end with the external dimensions and stuff. Small cuts and then checking, trial and error. That rattling on my lathe is just the fan at the back of the shaft, just rattling away. It needs to be keyed or something, but it never bothered me. Cooling's fine. I really lucked out here in the end because I took quite a heavy cut and just decided to stop and check, and it was spot on. And then I decided to use the same boring bar, just reduce the stick out, and do the final shoulder for the head of the cap head screw. And once again, it must be my lucky day, because I took a fairly heavy cut, no measuring, and just backed out and decided to check the fit, and it was perfect. Now just to flip it round and face off the back of it and add the shoulder, which will locate the saw blade. Just roughly centering the saw blade and marking roughly how far to machine, where the little register will be. And to my disbelief, again, perfect fit. I don't know what's going on today. So this is a 1.5mm thick carbide blade, and here I am trying a much thinner HSS blade. I think this one's a 0.8 or 0.6, so obviously you need to cut the shoulder shallow enough to fit the thinnest blade that you have. And here is the result. It's not bad at all for a couple of hours of work. Probably all in is about 60 quid or so. So it's not bad value at all. I did turn down that nut there just to give me a bit more clearance for my vice. But yeah, if you enjoyed this video, check out my other videos, and thanks for watching.